Okay. So today I'm going to talk about what else? RISC-V now. So I'm going to talk to you about some new custom use case on production, and also the NDIS code they use in action. And then I'm going to talk about RISC-V soon. That is NDIS upcoming product, and I'm going to give a takeaway, a conclusion. So this is a busy slide that Frank used. So this just to show that RISC-V now is in endpoint, edge, cloud, and automotive by NDIS. So we cover from mobile, MCU, MPU, storage, 5G networking, automotive, and last but one of our biggest market today is large-scale AI machine learning for probably past 4 years. So I'm going to talk about some of them, the most important part in the later slides. So first, storage application. So we know the AI has been growing like crazy, model getting bigger, data center grow with more machine. So storage company get benefit as well. So for NDIS has about 10 customer on storage or Oracle production. So this is one of the most important customer for us. So they come up with some market projection. So then fresh market share by application from 2025 to 2029. If you look at the mobile and PC, it's going from 66% and drop to 51%. But at the same time, data center usage of NAND flash go from 29% all the way to 44%. So Phison is one of our long-term customer and also leader in the SSD. So their PCIe controller solution are using our processor, starting from the client, probably 1 core, all the way to like 33 core in the Gen 4, like in the enterprise space. And now they are, and all of them are using N25F. And their new generation in Gen 6 would grow up to 50 core, and most of them will upgrade to our newer processor and 45. And Phison is our special customer. We talk about AI doing customization, acceleration, but Phison, the way they use to accelerate their storage application is also through ACE, so which is NDIS automated custom extension, our framework with toolchain to help customer to adding instruction. So you can see that Phison using ACE to connect to their different kind of accelerator, also control the memory management unit so that they can orchestrate their flash or different processing more efficiently. So again, we still need to go back to a large-scale AI machine learning. NDIS started with this from 2019, thanks to Meta, bring us to MTI data center accelerator using our vector processor in all the PE. And they also a big user of NDIS custom extension, use that to define instruction to interact orchestra with all their hardware accelerator like metric multiplication, transpose, DMA, and so on. So a lot of our customers doing similarly. I mean, those customers doing large-scale AI machine learning, like Dmetric, Axera, Fractile, and several other unnamed customers. So those are called large-scale AI machine learning, and mostly from cloud, or at least kind of more than 100 TOPS. But today I'm going to talk about new use case in the edge. So first is smart vision with agentic AI. That's from Novatech. They just talked about this in the RISC-V Now last week in Hsinchu. So in their SoC, it's relatively smaller, 32 TOPS, and come out from the 4 MPU. In the top level, they're using 2 N25F as a real-time control processor. And in their NPU, there's one real-time vector processor there, and control and work with their deep learning accelerator. And the vector length they use is 512 and 256 VLAN, DLAN. They define a lot of ACE instructions, so relative to, I think it's something like 30 or even more, so that they can put their own framework under their AI compiler. So their application is from surveillance, robot, drone, factory automation, and so on. And here is one application they already put together, their agentic AI active alarm. So they have a 16, so this chip controls 16 camera channel, and each channel they can detect the event, like whether there's a fight going on, a fire, a weapon, and so on. And then using agentic AI, so the panel is really like what is shown there, but just enlarge it so they can see it. So in this case, they detect one of the camera has some fire going on in the car. So it will issue the message called red pickup truck is on fire in garage with flame and smoke rising from the front. And they issue that, for example, go to a fire station or a police station. Right, so this is their application. Next one is smart glasses SoC for AI and also AR. Right? So we know smart glasses must be very low power and low heat because the form factor is very small. You cannot put a large battery, and also it cannot be too hot. So the feature of the SoC is that they support 12 megapixel and also 2K video, like Qualcomm's AR1 quality. It's used for display, it is for AR, and it can also capture for later AI analysis. And support super fast capture at 0.8 second. This is one of the places they use ACE to accelerate the computation. And also they have multi-layer wake up and gesture recognition. So these two are not from mental hospital. These two people, they are our colleagues. We visited a customer about 3 weeks ago in the lab, so they have the goggle. We can do a demo. So your hand is kind of looking at your display there. You can touch the virtual screen. You can recognize the operation of your command. But if you purely for AI, like Meta Raven's glasses, it will be like the bottom one, so which you can see through. So what does our code contribute? So we contribute on control, dispatch, and accelerate. They're using 4 of our 32-bit multi-core A45MP, and also the control processor and 25F, and all use ACE to accelerate the operation for things like hot function, like 40 cycle per second originally, and can accelerate it to 6x speed up. And they also have the ISP algorithm, which the whole thing takes 5 million cycle and speed up AX, also using ACE instruction. So it helps to speed up and also help to reduce the total energy consumption. The other one is a smart AI camera from the company. The brand name is Singmo. So the AI camera right now is already available in Taobao. So it soon come to Amazon. So it's like what you see here. So the left side is solar powered, all-in-one outdoor camera, and the other one is battery powered to put on the car, so-called parking dash cam with AI intelligent monitoring. So that's after you park your car, you shut down the engine, it's there to monitor whether there's a intruder or thing like that, right? So it's always on recording. So by what that it means that it's not really always recording, but it's monitoring the event happening with you with your defined event, then start doing recording. So, so it's a very low power mechanism there. So the benefit, so they're using our Core 827. So the benefit of it is that it provides very low power and very good power management, so that it can sustain very long time. And it has efficient memory subsystem because you need to control several of their peripheral. And also, one very important thing also unique about Andes is that customers require very small memory footprint. So they're using 32-bit Linux. And RISC-V as a whole already give up 32-bit Linux, but Andes cannot give up our customer. So we continue to support RV32 Linux with our processor. So the side note is that people talk about, I think Lindy talked about there are a data center guy, they're already running out of all the internet data for training. But I think the IoT devices, especially camera, will continue to provide a source of input for AI to continue training to understand the world. Right, so a trend in AI machine learning, well, I think one thing is certain is that it keeps evolving. So Lindy also talked about this because of the agentic AI, the workload for CPU continue to increase. So it used to be like something like 10%, now become the 50% of time we're spending on general purpose CPU, and the GPU time get reduced. Not the percentage-wise, but overall maybe both are get bigger. So in agentic AI, CPU do what planning, coding tool, making decision, and taking different action that will kind of go on CPU. But what does that mean to us? So I think what we learned in the past is that all the key ratios are constantly changing. As new application, new model emerge. Right? For example, between compute and control. Right? For us, it's a vector processor or scalar processor, or compute versus memory bandwidth. Right? So this is also changing. And the other one is the ratio between metric multiplication and one-dimension vector or scalar control. Right? So what we learned here is that this keeps changing. So what we do is that we provide our core with flexibility so customer can choose depending on their application and their particular usage. Right? So from here, I'm going to talk about a couple of our product lines. I started with Andes Vector Scalar Processor for AI and machine learning. It's starting from 5-stage single issue core N257V. That's the one that used by Meta for 2 generations. And then we kind of go up to a vector processor based on 8-stage dual issue core, the 45 series. And then 46 series, and then we have something coming down on the future. So all those, we have a common feature for the vector scalar processor used for AI, actually for all the Andes processor. We have automated custom extension, custom use it for different purposes. And for the vector processor, we support a wide range of format from INT8 to INT64, and 14.16 to 64, and bflow16. Andes bflow16 is a pioneer of RISC-V. We support the full arithmetic. It's not just doing the MEC, because our customers demanding all the full arithmetic so that they can move their algorithm to bflow16 much faster. Of course, in the future, I think we have to look into FP8 and FP4, hopefully that together with the RISC-V community. So what we are doing today is continue to do development is 46 series, but revision 2. 46 is a series which is already used by D-Matrix, Fractile, and several other customers for their AI application. But we find there's so many features that customers kind of demanding, so we separate that into phase 2 So we release that soon for the 46 series. That mostly come as a memory part of extension, like more outstanding capability, and also more parallel operation. And we also found that when we go from cloud to edge, RV32, that's 32-bit Linux, 32-bit application, still very important. So we're supporting that starting from the 46 series. And while we are doing 46, actually we already have some idea for the even next generation. So again, scalar will need to be continually enhanced because customers also feedback us that control performance is very important. And longer vector for those who need compute, metric extension, and more data format. So on the bottom, we also in parallel developing D23V, that's for the very endpoint vector processor. So we're going to talk about these two, the one with circle next. So 46, it already has quite a few features. So I summarize that with wide range of vector configuration from 128 all the way to 2024 and actually 2K. So it's 8-stage dual issue, but also can do the dual low or one low, one store. And it also supports high performance vector memory, we call HVM, that Dimitri already using it. So what is the new feature? So we continue to adding the latest RISC-V instruction, like ZCE, vector crypto, and FPA. We started with conversion. And also dynamic UXL, that is when you have RV32 Linux, which is mainstream, but you can run in 32-bit application, so that your 32-bit application can have port to 64-bit system much faster. And again, more memory subsystem performance. There are always many features to add it, such as more aggressive prefetch, even stronger outstanding capability, and accelerated coherence I/O. So that will be coming in our release too. And also, customers which are very heavy, rely on ACE to add instruction, they like to, for getting as many operand as possible for their processing or pass to the external accelerator. So that's why they're asking for 64-bit ACE instruction. So we enhance that. Even though today RISC-V is 64-bit instruction, still kind of in the process of changing it, but we add that for customer purpose and let them know that this may change in the future. And also, like we mentioned earlier, so customers tend to, as application evolve, tend to adjust their ratio of compute. Like for example, from their metric engine, usually our customers do that, our vector capability to scalar control. So to kind of, their customer has this configurability, so we define this what we call cluster heterogeneity. So that's for vector multi-core. So you can have mix of vector and scalar core. So at least one vector core, and the rest of them can be scalar or vector. So like I show on the right. And also each core can have a different ACE instruction to define, because some custom define heavy ACE instruction, they'll take up gate count, and customer care about compute intensity, so they want to make sure if they don't need that ACE instruction, they can attach that ACE to particular processor or some of the processors, but instead of everyone. Okay, so I should go back to the previous page. Oops, sorry. So here I forget to mention one thing. So for this processor, especially vector processor, we have a lot of configuration. Just look at the VLAN, DLAN. We support from 128 to 2024. But this is probably like four processors already in our competitors' space. Right? So they have fixed VLAN, DLAN as one product, and the other product is another VLAN, DLAN. But it all covered in our x86 MPV. All right, so D23V is a compact vector processor for endpoints. It basically built on top of our very popular compact core D23 plus the VPU. But to fit into this smaller domain, this VPU need to be much more efficient. So we support VLAN and DLAN from 64 just to 256. And it just used a natural pipeline. It would have arithmetic and memory so that to fully utilize the existing hardware. And the vector instruction may separate into micro operation, especially when LMR is not equal to 1. And you can start a micro operation if all the previous ones are known to be committed, even though it's still ongoing. As long as it won't generate exception, then you can start. So it would support chaining, and like I mentioned earlier, because of this level of code, we need to make it very compact. So it vector hardware sharing the floating point hardware between vector and scalar. And also in the memory access side, instead of very high performance HVM like we have in 46 MPV, you just use local memory and cache, and it can do efficiently fully pipeline and for both scalar and vector load store. Right, so next we talk about this FUSA processor roadmap, or we call safety enhanced roadmap. So this is what we already have. We have 3 FUSA core, N25F, D25F, and D45F SE. They cover different application scope. They're already available, already have serial customer on production. And then we are working on the so-called ultra low power line based on D23 SE, which we are working on it today, so should able to get the certification very soon. And then we take the D23V's vector version and to certify it with Automotive-Grade. And also, in parallel, we are working on a very small one, the 2-stage core. That's the request come from automotive large chip company. So in the top end, we based on 45, then we grow to 46. So Frank also talked about it. So we have 46, X46 SE, that our first 64-bit, and the core with support MMU with Automotive-Grade. This is with a US tier 1 autonomous driving company. We designed that for them. And later we're going to scale that into the full X46 MPV with Automotive-Grade. And the future grade core will be auto order based. So this is what we are working on right now. So we consider they're going to be available in this summer 3 months or before end of the year. So for a CFB processor, to kind of make sure you can have the enough diagnosis coverage, the software test library is very important. And since NDIS core all have many different configurations to support that, S-tier need to be flexibly structured. So when customer configure R-tier, the S-tier will automatically generate it with the feature that they selected. And it has fine-grained partition, so from the component level, like core, CSR, FPU, DSP, and so on. And each component has a lot of more smaller tests. So we separate that so that customer can do different adjustment for their need. So our S-tier can reach 90%. So you use full set, that's good for CFB. We have some customers, they just need a tier A level of product, so they can selectively remove some tests just to save the code size and also runtime. Okay, and then the next one is this 60 series of application processor. We have common feature like 13-stage pipeline, 4-deco auto-order execution, echo per cluster with shared cache. It's all Linux capable with hypervisor and AI support. That is for RVA 2023. So we have X65 already available. Actually, that's the only one which is not RVA 23, but RVA 22 Plus, and then X66, which is another like 15% performance up over 65. So in the RVA 23 scope, the vector is VLAN is support 128. It's not really for the large-scale AI computing, but for general purpose environment. So you have control, you have memory, you have everything there. Okay. And next generation we are planning, so it will another like 15-20% up there. But at this point, we also kind of based on looking at 66, we want to do a very efficient area power optimized version of we call X63. It's something like we would reduce the performance, but we reduce the code size and area, the gate count and the power even more. But it will be full RVA 23. So this tool would be available this year, and certainly starting from 66. Okay, so let's talk about software side. So in this side is our professional ID with a lot of components, full feature, starting from optimizing compiler, library, debugging environment, profiling analysis, and simulator, and so on. But I'm going to talk about a couple more unique ones in the coming page. So ND-Sentry is our security framework. So ND-Sentry T solution, trusted executing environment, starting from a hardware part, which is based on secure boot, which is based on the ND's code with PNP and ePNP processor, and then IOPNP supporting an SoC. And based on that, we go up, we provide a secure boot. And on top of that, secure monitor, that's kind of T, where the T is coming into place. So secure monitor help to segment your upper thread into different zones so that they are not able to kind of interfere with each other or kind of secure hold. So Opt is based on open source supporting RISC-V, supporting the Linux. And 64-bit is the standard there, which ND is working right to driving that activity. But ND is also supporting 32-bit Opt with 32-bit Linux for our customer. And in the non-Linux domain, there's no standard there. So ND is kind of started with our proprietary version we call MCUT, but it's basically a much smaller footprint. It's for RV32, and with MO and UMO. But it basically provides the same feature. You can segment application into different zones. And AutoOpTune is auto speed size optimization flag based on AI. So in this case, it shows that you can tune for code speed for one spec benchmark using LLVM on 45 MPV. So starting point is at 03 and with the enable vector on the far left. And after this is like 100 hours of trying different iteration based on the AI's tuning, you can get 30% reduction of the cycle. So about 30% of speed improvement. And the other one is if you want to tune for code size and speed, you can do that as well. So this is an example for this M-Bench IoT. So the second quadrant is the one that you have performance improved and also code size reduced. So that's the one that you can choose there. So the key takeaway here is RISC-V is happening now, and ND is leading the way to enable RISC-V for a wide range of applications. We already talked a lot in the past, from data center, cloud application, all the way to kind of edge. So ND is continued to strengthen our product for our customers. So in 2026, in this year, we will release Actually, Frank showed a couple of them, which I think we're going to redesign in the next 5 months or so. But before end of the year, we're going to have something like 10 different processor release. So I'm pretty excited and looking forward to those become RISC-V now as well. All right, thank you.